Very good afternoon to all of you, and I thank the organizer for inviting me for this very important, prestigious hydrogen need of the hour and how it can be utilized for the future. And I'll give some glimpse because you know that the fuel cell, when we talk about, is it the hydrogen application only through fuel cell for mobile application, or is it for the application through internal combustion engine? Both should be debated, and I think that is also open for the discussion. So having said that, just when I have just put this as a background slide, because we need to understand that in what way, right, the hydrogen has become so important, and since morning the lot of debates have been happened, so nothing to tell much. But if you look at in terms of the green fuel, where the product is only water compared to the fossil derived feedstocks, then there is a lot of advantage of hydrogen, provided that it can be produced efficiently, effectively, and that is the challenge for the future. But in that way, you see that compared to 7 to 8 kg of coal, the hydrogen is much more efficient, whether you talk about, right, it's for application in industry or for the vehicular application. But there are challenges also. You see that, right? The density is one of the important aspects when you talk about the volumetric basis, and that's why we need either liquid hydrogen or solid hydrogen. In the morning, there was a very good talk on the solid hydrogen also, or maybe in terms of the compressed form, and that is the, I think, the debate for the future, because the density where you can bring it to a level of 42 kg per meter cube versus 70 to 80 kg per meter cube, and that is where the thermodynamics and all this science engineering becomes very important, and lot of things are to be done in order to achieve that. This is where the challenge again with hydrogen. When you look at, right, the corrosion is huge, right? Most of the time you must have talked the transportation of hydrogen through the pipeline is still a challenge. And when you talk about permeability of the hydrogen and its brittleness, that has still made, right, lot of researchers to work in this area, and still R&D is active in this area. So that these points also should be addressed. Need not to say about, because since morning, lot of debate, lot of talks, lot of discussions on hydrogen production has been done. And if you look at, I am just focusing the point there at the top, right, that what percentage of hydrogen is available for the fuel. That's for vehicular application. So most of the time, when you look at, most of the hydrogen is being consumed by refineries, petrochemical and steel industry. And that is where, when we talk about, are we able to produce 19 million tons of hydrogen per year, which will be sufficient for the part of the hydrogen for the vehicular application. So gradual demand of the hydrogen for vehicular application will depend what are the different sources for producing the hydrogen at an economical prices, and that is where we are targeting $1, everybody is saying, but that is too optimistic. Even if we are getting hydrogen at the cost of 120 to 150 rupee, I think the job is done, and that is again point to thought. So I am just focusing on the top points here for this, because vehicular application is a big challenge when you talk about the mobility of hydrogen, and that is again a challenge for the future. So this is obvious, right? Everybody is talking that we need the low carbon products. Everybody is talking about by 2030, 1/3 of the carbon is to be removed. And also by 2070, the India has already promised that there will be net zero emission. And that is where we need to find out the technologies. When you talk about the second point, right, green hydrogen, it is promising, no doubt. Right? At the same time, we need to look at fuel cell application versus the internal combustion. I think both points should be discussed and debated. Of course, the fuel cell has lot of advantage compared to the internal combustion engine, and that is also very important. So these are where we talk about that already. So many things have been talked in terms of that by 2030, 55% of this, right? The reduction in terms of the emission cars. So that's what the lot of, right, the under G20 also it has been mentioned, and under lot of Paris and protocols which have been made for that net zero carbon. That is how this can be achieved through the vehicular application, and that is being done. So why this is happening? You see there, this is the point to ponder. Here the fuel cell, when you have the, right, regular fuel cells or fossil derived feedstock, there is a lot of carbon dioxide, but when you have this thing, you are able to reduce the carbon. But again, what is the source of hydrogen? So source of hydrogen can be fossil derived feedstock also, but even that, so, but if it is something like where we talk about the green hydrogen, then this is much more advantageous, and that is again very important, because this will give just the water. So that is where how much hydrogen is available for these applications, and the future will be in this direction when we are talking about hydrogen through the renewable feedstocks, and that will give the fuel, right, the clean energy, and that is where we are talking that are we able to reach the level number, the third, which is and that is where the future, that is where you talk about how hydrogen can be produced from the conventional matter, where we are talking about the blue hydrogen or pink hydrogen, right? Or you go through the sources where already the mandates are given, then 2 kg carbon dioxide is allowed to emit per kg of the hydrogen production. So that is where you can call that again green hydrogen. So biomass to hydrogen, which in the one of the sessions were debated, and that is again one of the very important area. The biomass, biogas, you convert into CNG, bio-CNG, and convert into hydrogen, and for that again lot of R&D and the technologies are up to TRL level 9. So this is where when you talk about, because I am focusing only on fuel cell here, so when you talk about what are the challenges, you have to understand what is a fuel cell, right? So you know that it has a source of hydrogen supply, ionization, ion and electron separation, oxygen reduction and water formation, and power generation. Every step has a challenge, right? Lot of fuel cell technologies are available, but there is need to work on these directions because there is a need to work how these can be worked. And as Professor Gupta was talking about, these are the different kind of fuel cells already, right, developed. And everybody talks about alkaline fuel cell, which is of course developed. Solid oxide fuel cells are also have good efficiency, but you see that I have marked it here in terms of red. The electrolyte development is still a challenge in almost all the cases, right? We need to look at in terms of that, this one. So what I was talking here, that these kind of challenges when you talk about the anode type, platinum anode, very costly. Who will buy this kind of anode? So we need to look at the platinum-free group metals, like it may be cobalt, it may be nickel. So those kind of anodes may be the futuristic approach when you look at these kind of, right, the materials. So electrolyte is a challenge, anode is a challenge, type, of course, solid, liquid, both kind of these materials can be used, and product is almost hydrogen. In some cases, when you talk about green hydrogen, or maybe the methanol also widely being used as a feedstock, or onboard reformers are also available. So how this can be used for vehicular application, that would be challenge, because storage, transportation, all these are an issue for the future, and that is where you see that everybody is talking about the efficiency part. So when you talk about these alkaline fuel cells and the solid oxide, they have the efficiency 60 to 70%. But still this number is low, and lot of things are to be done in order to improve the efficiency of these fuel cells. At the same time, the electrolyte is a big challenge, and that is where you see, right? When you talk about these kind of designs, so starting from your, right, economy is of course very important, that how much mileage you are able to get with a given vehicle, right, when you use the hydrogen as a source of feedstock, and then you compare it with respect to gasoline or diesel, existing engines, and how much emission per kilometer is coming, and what is the cost of that vehicle. So all these things will be very important, but at the same time, the logistics are much more challenging. Like when you talk about 3 to 5 minutes a charging type, definitely the fuel cell has the advantage. But when and that is the advantage over a battery when it takes 5 to 7 hours also, right? But so we need to have our hydrogen-based fuel cells. When you talk, the filling time should be similar like your existing gasoline or diesel engine, and that will be, I think, that what you see the lower portion of this, that how this kind of, right, the vehicles are to be designed, and a lot of vehicles are already available in commercial market, but the number is very less, and you see that how this number is now going on exponentially. And this is where the subject to the availability of the hydrogen for the future, we need to understand that how this number will go, whether this 100 millions of the vehicles when you talk about, or country-wise we have to decide how many vehicles can be designed and developed per year with respect to, right, these fuel cell vehicles, and efficiency-wise how important are these numbers, and that will be the challenge for the future. So what I say here, when you talk about for academicians, for researchers, for industrialists or R&D, everybody has the scope here in order to develop this kind of, right? So generation itself is a challenge. Everybody is talking about, right, when you talk about fuel cell application, how hydrogen will be generated. So PGM-free metal, which I am saying, right, so we have to work in this direction for as a catalyst for the PEM-based fuel cells. Then membrane, lot of, right, just now I had a discussion with one of the students also, this titanium is one of the material which is coming, because it is non-corrosive and it will have a longer life. But at the same time, the economy will come in picture when you talk about these kind of, right, membranes which will be generally used. high-performance electrolyte materials and fuel cell finally, which will come to the design. And there are plenty of opportunity to do R&D in these areas because we want low cost. That is I think the economic is very important, and finally life of these, because we are talking 60,000 hours for these kind of materials for fuel cell application, and that is where we need to. At the same time, for transportation, you need cylinders, right, pipeline to avoid hydrogen embrittlement, because these are also a challenge when you look at the fuel cells application hydrogen. So when you talk about electrolysis, there are a lot of, right, these kind of electrolyzers, solid oxide electrolyzer, PM-based electrolyte, alkaline-based electrolysis already. So I'm not going in detail, but these are the areas where we need to understand that how these numbers are appearing here. That water electrolysis, that 380,000 kg hydrogen per year, and that is where the consumption you see around 51 kilowatt hour per kg of hydrogen. So 50 to 80 kilowatt hour energy consumed per kg of the hydrogen. So are we at the level of 80 or 50, or are we able to reach below that? That will be the future for the commercialization of this kind of vehicle on an international market. At the same time, you see the electricity cost, 62%, if it is more than, right, overall, with this kind of alkaline. Alkaline is presently considered as the best because highest efficiency, and already the technology is well established. But when you talk about for small scale, right, 10 kg per day operations, then capital cost, right, which is approximately 60% of the total cost, power. So all these things are very challenging, and I think to be addressed for the future. This is just a couple of analysis which we have done at our R&D, that the 50% efficiency versus 75% efficiency. So if you are able to recover this heat from here, right, which is being rejected, and this is just, right, any onboard reformers can be used. So onboard methanol-based reformers are also being widely used. So this is a reformer you have generated up to 1 to 5 kilowatt, and people are working now 100 kilowatt scale also. So that is where the efficiency, which is 50%, if you are able to reject, right, capture this rejected heat, use it, and you can additional 25% efficiency per cycle. So overall efficiency can be improved to 75%. So this is also very important for future R&D, then how this can be done, and in what way effectively these kind of, right, technologies can be adopted for stationary or for vehicular applications. So already in the commercial market, in India also, Tata, Mahindra and Mahindra already, right, the expert from Mahindra is also there. IOC R&D has already hydrogen-based fuel cell. Recently, it has our Union Minister, Mr. Hardeep, has already launched this hydrogen-based vehicle also. So India is also jumping now into the hydrogen-based vehicle, right? Internal combustion engine, ICE-based, as well as fuel cell, both are being commercialized. But a lot of things are to be done when you look at the commercial market and international. See that for marine application also, and you must have heard about now, the jet engines or fighter planes can also be used, right, with hydrogen-based. So that is where the future, but, right, when you talk about this, storage is still a challenge on this side, the fuel cell module, the battery, right, power electronics, or design, and how these can be efficiently, lightweight materials, all these things will be very important for the efficiency in terms of the vehicle. So since time is short, so I'm just quickly coming that these are when you talk about the challenges and opportunities for the future, that infrastructure challenges for this kind of fuel cell vehicles, economic challenges, hydrogen production is biggest challenge, energy efficiency of the process, safety concern, limited vehicle models, and all these things, competition from battery, because e-vehicles are already in market, and there will be a huge competition between the e-vehicle and hydrogen-based vehicle, and that is also to be addressed if you want to commercialize it. So this is where, right, we work on these kind of R&Ds. So pipeline, transportation, because all these things are important. People are talking in terms of in the form of ammonia, but there are several issues with respect to ammonia also. And that is where, right, hydrogen liquefaction, cryogenic hydrogen, compressed hydrogen, and these will be the methods for storage. But again, in these, the material development has played a very important role, like this, what you say, how the hydrogen will be stored, right? In what way the technology can be adopted. So I'm not going in depth very quickly, I will just move. So liquid hydrogen, right, cryogenic hydrogen, these are coming up in a big way. As I said, 40 kg per meter cube density versus 80 kg per meter cube of density of the hydrogen, which can be achieved by availing the 70 bar pressure or by minus 220 or 270 degrees centigrade temperature. So both things can be done. It can be hybrid also, and that is like in the morning there was a talk on this hydrides, solid hydrogen, and these are, right, liquid organic hydrogen. This is also coming up in a big way. So a lot of things are to be in terms of R&D as well as for commercialization, TRL levels 5 to 6, so that these can be taken forward in future, because that will be the key to success for the vehicular application. So this is what I am not going in detail of this. Compressed hydrogen storage, right? Already carbon-based materials are developed for this, and they can go up to 700 bar. But the challenge is that people are thinking much higher type 4 already, right? Which is there in market, but 5, 6 are also coming in picture, and that is where we need to work in that. Similarly, this is, you see liquid hydrogen storage, so minus 253 degrees centigrade and atmospheric pressure, you can densify it to a level of 70 kg per meter cube, something like that, and these are the key to success for the future. So which technology, which kind of materials will be these, right? And that is where the future is very important to discuss about these kind of storage of hydrogen when you look at least 5 kilometer drive before you go for refill. This is again cryo-compressed. This is also being studied at 350 bar and minus 253. So you can trade off. And then this is the 100 weight % hydrogen. But what kind of material? What is the weight basis? So actuality 100 weight %. When you talk about on including the metal, it may come just 30 to 40 weight %. So that is again a challenge. Lightweight materials are very important when you talk about these kind of storage devices. So I think R&D as well as the academic and industry both have to join hand in order to work for this kind of material development for hydrogen. Liquid hydrogen, this is coming up in a big way. So you can select these kind of methyl cyclohexane, toluene, or any these kind of compounds which can have similar to like solid hydrogen. So this can have 6 to 8% the weight % of hydrogen, and this is sufficient for driving up to 500 kilometer, and after that you can. So this is everything is used in a closed loop, and that is where the concept of circular economy, no pollution to the environment, those are also kept in mind, and that is the things for the future. So if you look at here, right, some kind of R&D which is being done at IIT Roorkee also, so that is a kind of cylindrical PMFC, right? The idea is to reduce the surface area, and this will help again when you talk about in terms of the weight. You see here 50 gram versus 1500 gram for this kind of planar cell versus cylindrical cell. So this is at R&D level at Roorkee. So we are working on these kind of, so power delivered, you see 1.6 watt versus 2 watt, and cost is also minimum, but at its infant stage, and again this is to be taken forward. So challenges are there, right? But at the same time, there are opportunities also. So this is what to be done, right? All the manufacturers, right, they have to follow the guidelines, right? Must bring the hydrogen mobility products, safety, which is very important, safely to the market, then compliance to the existing regulation, that will play an important role. Already BIS norms have been discussed, and these are being prepared now for hydrogen transportation. Fueling a hydrogen car, right, that is aligning a heavy nozzle and sealing it. So a lot of mechanical things will come in picture, the mechanical electronics, so how these things can be taken care. And that is where you talk about, just like an example, the best selling hydrogen car, if you look at in India, is in US is 90 kilowatt, 120 horsepower, but this is not enough, right, to accelerate a fast moving highway like Toyota. They have just trying to work on redesigning, so high voltage, low capacity battery. So that is also very important, the pickup and all these things which is generally used, right? So how fast this can be compared with the gasoline based vehicles or electric vehicles. So before concluding, I am just talking these terms. So these are the way forward for the future. So we need to work on this novel, right, electrode materials, membrane materials, flow field design, leading to high efficiency, durability, cost. All these things are still the challenges for mobile fuel cell applications, right? The cost is very high, that is the vehicle production for hydrogen fuel cell technology, and there is a lack of refueling infrastructure, so that should be considered. Advancement in technology, economy of the scale, R&D, all these things are to be done. And I think the collaboration is very important. Promote the consumer awareness, education, because safety of, right, with respect to hydrogen-based vehicles is very important. Invest in marketing and educational campaigns to raise, like in the morning also there was that hydrogen-based courses. So a lot of already the Center for Sustainable Energy and all these types of centers are already existing in IITs, NITs, or all educational institutes under this HEI, Higher Education NEP 2020, and lot of, right, courses on hydrogen are also being, right, started or already started in many educational institutes. So that is again, right, which is required. So this is the, I think, the overall which I would like to, right, convey from my side. Thank you very much for your patience hearing, and if there are any questions, I'll be happy to answer. Thank you.